So the Kotlin library has different types of collections. The one that we've been looking at so far is the list of, in this case, immutable and mutable list of. So these are implementation of list, right, collection. Now there's another type of relevant collection type. There are two types actually, set and map. So what is a set? A set is a collection of unique elements, and the order is not important in a set. Let's go ahead and see how that works. So let's get rid of these guys. And here I'm going to say val my set, and I'm going to create a set of, and I'm going to pass an element here. I'm going to say us mz au. Okay, that's enough. So now let's go ahead and print this. I'm going to say print ln, say my set. Let's see what's going to happen. All right, so there it is, us mz au. Now, although it looks the same as a list or mutable list, a set has a few different properties, one of which is that it stores unique elements and their order is generally undefined. So there's no order, even though we saw that this is ordered here. But if you keep adding more items, there's really no order that is defined. Okay. As we said, this is just a set of, it's pretty much just like list of, which means this is immutable. So I can't say, for instance, my set dot add. You notice that's not going to work. So what do you think would allow me to make a mutable set? Yes, I will have to say something. Val my mutable set. I'm going to say mutable set of, and I can of course pass elements such as this. In this case, I can just pass just a few numbers like that, and I can say now my mutable set dot add, and I can add, for instance, 34, and then down here I can just say my mutable set. You'll see that we should get all the numbers. The other thing we'll notice that is very interesting, if I try to add, let's say 3, let's see what's going to happen. Right, you notice that a set in this case only allows unique values. I'll show you something interesting. If I go back to my mutable list here, we know it's mutable, so I'm going to add something to it. So my mutable list, let's add a number that we already know it exists. Let's add another 34, and we're going to go ahead and print ln my mutable list, that is. Okay, so you can see what's happening here. Let's go ahead and run, and you will see we have 13, 12, 34, 45, 13, and 34 is repeated again. So one of the differences here is that a mutable list, right, or list in general, we can have repeating values. Because you can see here, we have 12, 34, 45, 12, 1, 23, and 34 again. However, we try to add to our mutable set 3, because it already contains 3, it just ignores that, right? It doesn't add 3. But if we add a different number, if you run this, we should see 123 added to our set. So here we have set. All right, the next collection type, so we have list, we talked about set and its different implementations, right? Set of, this is immutable, and mutable set of is mutable. So you see the trend here. The next one is map, right? I like maps because I'll show you why. So maps. So a map, as the name implies, allows us to map values. So we can say, for instance, A maps to 1, C maps to 10, and so forth. So we have this key value pair relationship that we can add. Okay, let's go ahead and create one. So I'm going to go ahead and say val, call this secret map. I'm going to use a map of, yes. And you can see here in this function, it says it's a pair. So it's a pair. We have key and value. Now the syntax may be very strange because we haven't talked about classes or objects and so forth. But what we're saying here is that it's going to require a pair of key value pairs, right? So map of, in this case, this is immutable. Yes, you guessed that. So what we're going to do here, so we're going to say first we're going to put a key and then map it to a value. So in this case, I could start a key with a type. In this case, it can be anything. I'm going to start with a key of string type. I'm going to say, for instance, up like this, And I'm going to say it's going to map to what? I'm going to map it to 1, for instance. And then I'm going to say down key. I'm going to map it to 2. Say left. I'm going to say 2. Map to 3. And then I'm going to continue right. I'm going to map this to 4 as such. All right, as we do, I'm going to print ln secret map as such. Let's go ahead and comment these out so we don't have all these prints showing up here. I'm going to run, and voila, you can see there is a string representation. So up is equal to 1, down is equal to 2, left 3, and so forth. And the great thing here, we can also go, for instance, if I want to get all the keys, I can just a secret map like that and say dot keys, right? It's going to give a set of strings of keys. If I run this, we're going to see all the keys. So up, down, left, right. The same thing, we can go and get the entries in this case, or in this case, I'm just going to go ahead and get the values. Okay, I'm going to say values. Should get all the numbers 1, 2, 3, 4. Another thing we can do, we can actually check. We can say, for instance, if up is in our secret map like this, then I want to print ln yes is in, something like that. Let's go and run, and you can see yes is in because up indeed is in secret map. So what happens here is going to go and check to see if there is up inside of our secret map val there. Same way, I can do something like this. If, again, let's say if 4 in secret map and get the values, I say print yes is in. Is there 4 there? We should see another yes is in. So we have 2 yeses there. And as always, we are also able to add something to our map. Obviously not the map of. We will have to create, yes, you guessed it, we have to create another mutable secret map. Very long names, but it's okay. So we'll say mutable, let's see, mutable map of, there we go. In this case here, I'm going to say 1 is going to be a map to 1, 2, 2 like this, 3, 2, 3. So now I can actually add. So my mutable secret map, I can say dot add. So for a set, we don't have add, we have put actually. So I'm going to say dot put. You can see it says here we can pass, there's a different kind of puts, right? We can put the pairs in iterable and so forth. Let's go ahead and use the most simple one. So put, we can put key and value. So the key is going to be, I'm going to say 4, and then the value is going to be number 4. Looks like it doesn't quite like this. I'm going to just go say Alt enter or Option enter, and then I'm going to convert that to assignment like this. So looks like it prefers to pass the square brackets like this and pass 4 and then set equal like that. Either way works, just a preference of the IDE. So now if I actually just go ahead and print ln my mutable secret map, we should see that another key value pair was added. And voila, you can see there's 1, 2, 3, and 4. All right, so this is very basics, but I hope it gets you in the frame of mind here of understanding, okay, the things that we have at our disposal to use in Kotlin when it comes to collections. Okay, there are a lot of other things you can do with collections, obviously, that would take probably 20 hours, but this is the basics and the fundamentals, so for you to understand how collections work in Kotlin. Okay, so now you can be very dangerous because you understand or you've learned a lot of things. So go back and get a cup of coffee or whatever it is that you drink and relax and think about the things that you can do now as a Kotlin programmer. All right, I'll see you in the next video.